Please welcome Serge Cosnier, University Grenoble Alpes.
I am Serge Cosnier, Director of Research at CNRS, and I am the head of the research team on bioelectrochemistry at the University of Grenoble Alpes in France. Today I am going to introduce you to the startup BeFC, which is specialized in the fabrication of biofuel cells as an energy source. This approach is totally revolutionary because they can produce electricity from sugar and oxygen with a totally biodegradable system. Indeed, they designed an original concept of biofuel cells based on enzyme and paper for single use. Unlike a button battery, which are a major source of pollution and requires metal and compounds whose resources are limited, they use elements like cellulose and paper, which are widely available on the planet. Despite significant technological advances in the early of 2000, no industrialization of biofuel cells had taken place. BeFC is the first and the only one to have succeeded in the industrialization of this product.
Breaking the wall between electronics disposal and sustainability. Jules Hammond, BeFC.
Hi everyone, my name is Jules Hammond and I'm the CEO and co-founder at BeFC. In one sentence, BeFC produce electricity with papers and enzymes. Our startup is reinventing the way we power microelectronics. We live in a smart and connected world, but the portable devices we use are typically powered by miniature batteries, which are complex, expensive, and unecological to first collect, process, then recycle. As a consequence, last year, approximately 15 billion primary batteries, or 97% of miniature batteries, ended up being discarded in landfill or were incinerated, polluting our planet. But today, I'm happy to be here to present BeFC's sustainable alternative. We provide a bio-sourced and bio-inspired energy solution. We produce paper biofuel cells, and being paper-based, they're thin, lightweight, and flexible, a perfect form factor for integration into packaging and wearables. And unlike batteries that store energy using reactive metals, BeFC uses enzymes, natural catalysts that convert biofuels into electricity. And we use abundant biofuels, glucose and oxygen, and this harks back to our research group's work on implantable biofuel cells, harvesting the energy from the bloodstream to power devices like pacemakers and insulin pumps. In fact, as Serge said, our research group was the first in the world to implant such devices into mammals. But maybe more importantly, BeFC uses organic materials, and this means our energy solution is completely compostable, completely reducing the environmental impact at the end of life, and also meaning that we're breaking down the wall between electronics disposal and sustainability. But our vision doesn't stop at our organic energy solution. Our mission at BeFC is to provide low-cost, low environmental impact electronic solutions. We want to provide data opportunities without the downsides of battery disposal. And with our strategic partners, we've already worked on reducing the amount of electronic components while still offering a rich feature set. We've demonstrated sensors including temperature, humidity, pressure, light, and shock, and wireless communication through NFC, Bluetooth Low Energy Beacon, and even sub-gigahertz protocols Sigfox and LoRaWAN, enabling us to send data tens of kilometers away. Now BeFC is going a step further. We've started to print the electrical wires, the antennae, and even simple sensors to completely minimize the electronic waste. BeFC was founded in May 2020 by a handful of academics, but we've since grown to 40 employees with backgrounds in science, engineering, and business. But at BeFC, we believe to provide innovative solutions to the challenges that we face, we have to open our arms up to diversity. We raised 3 million euros of seed funding 1 month after incorporating, and we've used that to optimize the material selection, reducing cost, improving performance, but most importantly, transitioning to a roll-to-roll printed manufacturing process. Our disruptive technology has gained the interest of industrial customers, and today we have over 2 million euros of contracts in markets including logistics, single-use medical devices, packaging, IoT, as well as wearables. But today, BeFC are looking to raise a 50 million euro Series A fund to allow us to finalize the transition of industrial scale-up, to internationalize our business development, and to complete our transition to printed sensors. Now, what I would say is the reason I stand here is that BeFC are looking for forward-thinking customers, strategic partners, and also visionary investors, because together we can power the future of nature. Thank you.
So, let's move on for questions here. Let's go back to the 4 minutes, even if you were actually 1 minute early. Who would like to start? Yes, please, Hemai.
So I think you were previously working with implantables and have now gone to wearables. Why was that, and do you have a first product in mind?
Sure, so the reason to pivot away from implantable is FDA regulation, really long and complex, and BeFC is a CNRS spin-off, and we had 7 patents that we decided that we wanted to exploit more rapidly. So our first proof of concept was actually working with a digital pregnancy and ovulation test manufacturer. And after this, we decided there must be an opportunity to also extend this paper biofuel cell to other single-use or short lifetime applications.
Okay, the next question is back here, please. Yes, thank you.
You mentioned a number of applications that you could use. I'm curious which one you're most excited about.
Personally, long-term on the medical applications, it will be slightly slower. The first use cases you'll see this technology in is logistics monitoring. Monitoring things like temperature and humidity of pharmaceuticals and also shock of high-value assets. But long-term, I think you can use this to energize a range of medical tests that can be single-use, throw away, reduce the burden on clinicians, and have a sustainable future.
We have a question from Stefan here at the front. Thank you for the microphone.
Fascinating. Could you talk a bit about the storage capacity of your new batteries compared to regular ones?
Sure. So after years of optimization, we're similar today to alkaline thin film battery technologies. So we can provide around 11 milliwatt hour per square centimeter. If you need more power or energy, you increase the surface area. We're not going to be able to compete with lithium today, but long term, if we cascade the enzyme reactions, we can actually extract more energy than lithium-based technologies. The challenge is keeping the enzyme stable for long periods of time. In 2015, we had a Nature publication where we kept the enzyme stable for 1 year in operational conditions, albeit refrigerated. But realistically today, this is used for applications from minutes to months.
We have a next question here, and then we will take Martin, please.
Hello, is the technology for scale production ready?
Yes, we traditionally used what we call a sheet-to-sheet process, but we've now transitioned to high-speed printing, so flexographic and rotary screen printing, and we estimate we can produce 1 million of these per day. And the price point by moving to this industrial manufacturing process is units of cent, so to compete directly with alkaline-based batteries.
Mm-hmm. Next, then Martin, please.
In 2 sentences, what are the enzymes doing, and how stable are they?
Okay. Very stable. We use one enzyme to oxidize glucose, and we use a second enzyme to reduce oxygen into water. And for 40 years, we've been the world leaders in biosensing and then biofuel cells, stabilizing these enzymes on electrodes.
We would have time for a last question. Anyone? No? Yep, here, last row. You still have 50 seconds.
I'm curious why you chose high impact applications, in the sense that if your battery fails, there might be, I don't know, loss of life or something like that. If you're going for medical, why not go for a low hanging fruit? Is it because of margins, or what's the thinking behind applying these batteries to these?
I would say our business model is to go for the low-hanging fruit. Logistics, our lead customer, is looking at 180 million units per year to track a wide range of high-value assets. Single-use medical tests, for instance, pregnancy tests, we produce a sub-assembly. Our device manufacturers then do the MDR. But we're confident that the performance of this can sustain, these types of applications.
Thank you very much.
Thank
Perfectly in time. Good way back to Grenoble, because you're going to Grenoble.